Welcome to Mathletes. I'm Gori, and today we'll be tackling trigonometry. I'll be doing every exam question ever asked in HSC Standard 1 Maths over the last 5 years. So grab a pen and let's get started.
All right, HSC Maths Standard 1. This is every exam question ever asked on trigonometry. A map of a park containing a duck pond is shown. A fence is built, passing through the points A, B, and C around the duck pond. Using the scale provided on the map, calculate the length of the fence AB. All right, so we can just count up the squares here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I count 15 squares. I'm just going to write that. 15 squares. And the scale shows us that every time there's 2 squares, that's equal to 10 millimeters. So if we take our 15 and divide it by 2, that's going to give us 7.5. And then 7.5 times 10 is equal to 75 meters. And that's the length of AB. And, let's check the answer. Yep, 75 meters. All right. Question 20 continued. We're going to look at part C because this is the part that's trigonometry. What is the true bearing of point A from point C? So looking at our diagram again, what is the true bearing of point A from point C? So point C is our frame of reference here. And when it asks for the true bearing, what it's asking for is the angle that's going all the way around here, right? So to find this angle, what we want to know is this angle here. We're going to call that theta. And we knew from part A that this is 75 meters. And counting up the squares on this other side, B to C, 2, 4, 6, 8, 10, 12, 14, 15. So this is also 75 meters, which means this is an isosceles triangle. We also know that this is a right angle just here. And quite simply, we're going to use the tan ratio. So taking this 75 and this 75, go like this. Tan theta is equal to 75 over 75, which is, in other words, 1. And we know that theta is equal to 45 degrees because tan 45 is equal to 1. All right, so now that we know that this angle here is 45 degrees, the true bearing is going to be 270, which is up to this line, take away 45 degrees. So the true bearing is 270 take away 45 degrees, which is equal to, just using my calculator, 270 minus 45, 225. There we go. That's our answer. Okay, moving on. Consider the diagram shown. Which of the following is the correct expression for the length x? All right, so looking at the triangle from the perspective of this angle here, this is adjacent, this is opposite, this side, and this is the hypotenuse. So if we want side x, it's going to be cos. So cos the angle is equal to adjacent over hypotenuse. All right, so cos 40 is equal to x over 20. And you can see that they've rearranged it to make x the subject of the equation. So x is equal to 20 cos 40. So that's our answer, A. Yep. Question 14. A hotel is located 186 meters north and 50 meters west of a train station. What is the bearing of the hotel from the train station? Round your answer to the nearest degree. Okay, so what it's asking for is what this angle is all the way around here. All right, that's what we're after. And to get that angle, all we're going to do is minus this angle here. We're going to call it theta whenever we don't know what the angle is. So we can use the ratio of these two sides to figure out what theta is and then minus it from 360 to get this big angle that we're looking for. So tan theta is equal to 50 over 186. And putting that into my calculator, it's going to spit out a number for theta, and that's going to be 15 degrees and 3 minutes. So now to find out our big angle there, it's going to be 360 minus 15 degrees, 3 minutes, which is going to be 344.57, which is approximately 345 degrees. Great. Question 25. In a national park, a straight path connects a lookout to a car park. The lookout is 35 meters higher than the car park. The path is inclined at an angle of elevation of 4 degrees as shown. What is the length of the path correct to the nearest meter? All right. So if we call the path x, then we simply say, well, this one is the opposite side and this one is the hypotenuse. So we're looking for sine. Sine 4 degrees is equal to 35 over x. So we rearrange this to make x the subject. X is equal to 35 divided by sine 4. So we plug that into our calculator and we get 35 divided by sine 4. 501.745, but it asked for it correct to the nearest meter. So we're going to round up to 502 meters. There it is. Question 16. From the top of a vertical cliff 120 meters high, a boat is observed. The angle of depression of the boat from the top of the cliff is 18 degrees as shown in the diagram. Find the distance of the boat from the base of the cliff. Give your answer to the nearest meter. All right, so these two angles add up to 90 degrees. So therefore, this angle here, theta, is equal to 90 degrees minus 18 degrees, which is equal to 72 degrees. 72 degrees. All right, now we simply use tan. So tan 72 degrees is equal to, this is the distance that we're after, x, the distance between the boat and the cliff. So tan 72 is equal to x over 120. Rearranging this to make x the subject gives us 120 times tan 72 degrees equals x. So just plugging that into our calculator, we get 120 times tan 72 equals 369.322. And it wants the answer to the nearest meter. So that is going to be 369 meters. And that's our answer. Question 29. The diagram shows the location of 3 places, X, Y, and C. Y is on a bearing of 120 degrees and 15 kilometers from X. C is 40 kilometers from X and lies due west of Y. P lies on the line joining C and Y and is due south of X. All right. Find the distance from X to P. All right. So we'll immediately call that distance X. And we already have this side here to work with, 15. And what would be helpful is if we had an angle over here to work with as well. And this angle, it's going to simply be 180 degrees. Take away 120, which is equal to 60 degrees. So call that 60 degrees. And then we can just write cos 60 degrees is equal to x on 15. And then rearranging that, x is equal to 15 times cos 60. Cos 60 is half times 15, so we get 7.5. And that's going to be kilometers. Make sure you put your units in. All right, what is the bearing of C from X to the nearest degree? So what we want is this bearing, this angle, the whole way around. And to get that, we're going to find out what theta is, this angle just here. So theta is going to be cos theta is equal to 7.5 over 40. So theta, if we plug that into our calculator, it gives us 79 degrees, 12 minutes. Right, so then we simply need to add that number to 180. The bearing is equal to 180 plus 79 degrees, 12 minutes. Okay, putting that into our calculator, we get 259 degrees, 12 minutes. And then it wants the answer to the nearest degree. So we're going to round that down to 259 degrees. There's our answer. 259. Great. Question 28. A right angle triangle XYZ is shown. The length of XZ is 16 centimeters. XZ, yep, 16 centimeters. And angle YXZ is 30 degrees. Find the side of length XY of the triangle in centimeters correct to 2 decimal places. All right. So we simply write cos 30 degrees is equal to xy over 16. So then 16 times cos 30 is equal to xy. Plugging that into our calculator, 16 times cos 30 gives us 13.8564. And they want it corrected 2 decimal places. All right, so it's going to be 13.86 centimeters is our answer. Hence, find the area of the triangle XYZ in square centimeters correct to 1 decimal place. So I think we're going to use a bit of Pythagoras here. We need to figure out what this side is, YZ, and then we can use our area of a triangle formula. So a squared plus b squared equals c squared. In this case, we're looking for one of the sides. So b squared equals c squared minus a squared. And b is equal to the square root of c squared minus a squared. So our side, YZ, is equal to c squared is 16 squared. Take away xy is 13.86 squared. Right, so let's plug that into our calculator. 16 squared minus 13.86 squared. And then we square root that, and we get 7.99377. Okay, and then we want to find the area of the triangle. So that's going to be A is equal to half base times height, which is equal to half. Our base is 13.86 times our height, which is 7.99377. Let's multiply those numbers together. 13.86 and then divided by 2. So that gives us an area of 55.396. And they want it correct to 1 decimal place. So 15.4 centimeters squared. 55.4. Yep. And 13.86. Great. That's it.